Okay, MacMaths, let's do some maths today. Okay guys, since my last lesson, lesson 3, just had a quick cup of tea. I got a text from Jeff's wife actually. She said he was 111, so I texted him to say happy birthday. But no, I misunderstood, he's ill is what she meant, so worried about the COVID, phoned him up. Actually he's okay, just strained his back doing his yoga, but he's okay, silly old fool. And I'm back and I'm looking at exercise 3A, and this is supporting the lesson 3A, and this is supporting exercise 11C. So I'm going to just do some selected questions for you. First of all, just rushing through these early ones, the simplest ones, the magnitude of 4i plus 7j. So that's just, I always like to draw the diagram. So 4i, 7j, 4 and 7. Okay, so get into the habit of doing your diagram. Okay, and then just do the maths on that. So 4 squared plus 7 squared is 16 plus 49. So it's the square root of those. So that's the square root of 65. And we'll leave that as an exact value. So the magnitude of this, remember we see these lines, don't we, is root 65. The unit vector, I did explain why we use that. So we're looking at the unit vector of this. We need to know the magnitude of it. Again, I always like to draw a diagram. So this is 1 along, that's my I, minus 3. So there's my minus 3. It's 1 along and down 3. We need to know that distance, don't we? Okay, and that distance there is the magnitude of 1 squared plus 3 squared. Minus 3 squared is 9, isn't it? A positive 9. So this is root 10 by Pythagoras. Okay, so remember the unit vector is just 1 unit along there. If that was 5 long, it would be a fifth. It's root 10 long, so it's a root 10th. Okay, so it's a root 10th of I minus 3j, isn't it? And that is question 3D, but they're all the same in that. Question 4, there's several of them. This is just the last one. The angle it makes with the positive x-axis. That's what it says. I've just shortened the question. The positive x-axis. So it means in that direction. Okay, that's the positive x-axis. Sometimes it says with the direction I, same thing. So 2i plus 4j. So 2 along and up 4. So 2 along and up 4. Okay, so it's this angle here. Okay, so that is the inverse tan, isn't it, of opposite over adjacent. So the tan to the minus 1, 4 over 2, because the tan of this angle here is opposite over adjacent, which is the tan ratio. So the tan to the minus 1 of 2 I wrote that down somewhere, is 63.4 degrees to 1 decimal place. We always go 1 decimal place with angles. That's accurate enough, isn't it, for every mathematician. Okay, question 5 says it's the same as question 4. It says the angle with the positive y-axis. Okay, so with question 5, you're just finding that angle there from the y-axis, turning from the y-axis. So just do the same maths as what we've done here, and just take that away from 90 degrees. Don't you? Take that away from 90 degrees and you'll get that angle there. So that's all that one is. Question 6, it's one of these reverse. It gives you the magnitude and a direction it's running in. So 6D looks like this in the book. So it says it has a magnitude of 5. And okay, so if it has a magnitude of 5, first of all, remember, you know, that's my I. And that's my j. It wants it in the I and j form, so I draw my I and j triangle. This is the angle that I'm going to use anyway, which is theta here, and that of course is 30 degrees, isn't it? Okay, so that's 30 degrees. So this 30-degree angle in my little triangle, okay, so this is the x part of it, and that is the y part of it, isn't it? You know, that is the along the corridor, and in this case down the stairs. So if we find the x part of that, we know that the sine of 30 degrees is, oh, hang on a minute. We know that the cos of 30 degrees, the cos of that angle, is adjacent over hypotenuse. So x and that hypotenuse is 5, because that's the magnitude of the vector that they've given us. So x over 5, so from our lesson last, you can see 5 cos 30, and y there is going to be, although it's going down, it doesn't matter, it's 5 sine 30, because sine is opposite. Sine of 30 degrees is opposite, which is y over 5, opposite to the angle over 5. Okay, so in I and j, quite simply, we've got 5 cos 30 I plus 5 sine 30 j. And I've not looked at the answers in the back of the book, but they may have worked out what 5 cos 30 and 5 sine 30 is. Indeed, you know, 5, you know that sine 30 is a half, so they might have it as 2.5, you know, 2.5 j. Cos 30 is root 3 over 2, so they may have it as 5 root 3 over 2 I plus, you know, 2.5 j. They may have, or 2.5 j, or 5 over 2 j. They may have it like that in the back. Okay, so those are the easy ones. That takes you up to 6. I'm going to go through some of them, the harder ones, you know, in that exercise. So have a go at them first. Do have a go at them first, and then you can watch the video, and you can put them, you know, on pause, and watch me do them. So the first one I'm going to do is this one, number 8. So number 8 says, given that the magnitude of 2i minus kj is 2 root 10, find the exact value of k. Okay, so the magnitude of this, of course, this vector here is, you know, it's 2i minus, you know, it's 2i along minus k going down there. That's the magnitude of it. And we find that by Pythagoras. Okay, so using Pythagoras for this, we know that this is the square root, isn't it, of 2 squared plus, if you like, minus k squared. And that, of course, is equal to 2 root 10. Okay. So it tells you that the magnitude of this, and the magnitude, of course, we find the magnitude of it, the length of it, by using Pythagoras, is equal to 2 root 10. If we square both sides of this equation, we unlock, don't we, what's underneath here? We get 2 squared plus minus k squared on this side. And 2 squared plus minus k squared is 4, plus minus k times minus k is plus k squared. So by squaring this side, we get 4 plus k squared. Squaring this side, of course, we get all of that squared. 2 root 10 times 2 root 10 is 2 times 2, which is 4, times root 10 times root 10, which is 10, which is, so the whole thing is 40. That squared is 40. Because it's 2 times root 10 times 2 times root 10. Don't be doing the crab's claw on that. Rearranging that. 2 times 2 is 4. Root 10 times root 10 is 10. And 4 times 10 is 40. So we've got 4 plus k squared is equal to 40. Take 4 off both sides. K squared is equal to 36. And square root both sides. And be careful, this is A level, so when we square root that, k can actually be plus or minus 6. Bit unusual this. It says find the exact value of k. That implies that it's not a nice whole number, which of course it is in this case. So when you get that on an exam, that exact value, it's always something that is in surd form or in terms of pi or something like that. So just be careful. Okay, but it is an exact answer in this case. Okay, so that's number 8. Put it on pause, the video on pause, have a go at number 9. Okay, if you're just coming off the pause now, give me time to rub it out. I've got this one now. So it says that vector A is pi plus qj. So let's just go, and it has a magnitude of 10. There we go. And the angle theta with the positive x-axis, this is the x-axis here, the sine of theta is 3/5. Okay, so let's just do this one. Sine of theta, let's look at the angle first of all. The sine of theta is 3/5. Now, sine theta is equal to opposite over hypotenuse. So if it's 3/5, you can see that the opposite is 3 and the hypotenuse must be 5. Then you can see that actually this is, we've done this on purpose, this is the 3, 4, 5 triangle. Okay. Now what we could do is with that is we know that's not the vector because the vector that we want has a magnitude of 10. So we could find, you know, the unit vector of this, couldn't we? You know, this is the vector 4i plus 3j, and we could find the unit vector of this, which is a fifth, you know, it's just one along, and we want to make that, for that's 1 unit, but we want 10 units, so we times this by 10, so 10/5 of that, and 10/5 of course is 2. So we could go down that route, but you probably spotted they've made it really nice and easy. Actually, this is the direction, and this gives you a magnitude of 5, but we actually want 10, so we just double everything. Okay, and if we have the triangle sort of 6, 8, 10 here, okay, that's just double all of these values. Theta is still 6/8, which is cancels down to 3/5, and we've got the right magnitude. So in other words, Q is 6 and P is 8. That gives us a direction of sine theta equals 3/5, and of course 6, 8, 10 gives us a magnitude of 10. So those are the two possible values of P and Q. Okay, that's that one. That was actually quite straightforward, wasn't it? Okay, again, let's have a look at number 10. Number 10 is starting to look a little bit more tricky. This one here, okay, so let's have a look at it. Number 10 says find the angle AB. So this is the triangle that they give you. Okay, so there's AB, and there's AC, and I draw it nice and big down here, B and A. And it says part A, it says find the angle between AB and I. Okay, so I is that direction, so that's the I direction. It's the same as the, you know, the positive X direction, positive I direction. So it wants this angle here, okay, between AB and I. And of course, this is AB is 4 along and 3 up. Okay, so 4 along and 3 up. So this is this angle here. So it's the inverse tan to the minus 1 of 3/4, isn't it? And that gives us actually 36.9 degrees if you do the inverse tan of 3/4. That's that one. If you did the same with this one here, it says find the angle AC, that's that one, and I, so it's asking you to find, let's use, I don't know, mu, okay, that angle there. Well, we've got, what is that one, 6i minus 4, so it's 6 along, and I like to draw the diagram, you know, so it's 4 down, it's down there, so it's minus 4, so that's our mu, okay, and the tan of, it doesn't have, you know, it's just 4 down, the minus doesn't need to be there, so the tan to the minus 1 of opposite over adjacent is 4/6, so the tan to the minus 1 of 4/6, that would be mu, and that would give us 33.6 degrees. Okay, so that's at the angle below the horizontal. Okay, if you were writing this as an answer, you'd have to qualify that, you know, so if you're working out the angle, you'd have to say that it's 36.9 above the horizontal, and you'd have to say that it was this one was 33.6 below the horizontal, just to distinguish between the two. And it finishes by just saying, hence find the angle BAC. BAC is that one, so we just add those two together. They may have done it more accurately in the back, okay, but I can see from just looking at those two that is 70.5 degrees, okay, so it'll be there or thereabouts in the back. Okay, so that is question 10. Question 11, okay, put it on pause, just a little bit more to it, but actually you're doing the same thing. So question 11 gives you a similar looking triangle. Sorry as I lean across, because I've just put some little bits of working out for myself, so I can just speed things up. Question 11 does the same thing. You know, it gives you P, Q, and R down here, and it tells you that PQ is PQ from there to there is 4I plus J, so we can work out that one, 4 and 1, and PR from there to there is 6 and 8. Well, that's nice and easy actually, isn't it? 6 and 8 down, so that one is 10. We can do that. This one by Pythagoras, 4 squared plus 1 squared, 16. I'm getting ahead of myself here, is root 17. Okay, because what it actually, I'm actually sort of in my head sort of going on to the last bit, but here it says find the size of angle QPR. Well, we do that the same as we did that first one. So the one that I've just done, if you did that, if you did the inverse tan of 1 over 4, you'd get 14 degrees. And if you did the inverse tan of 8 over 6, you know, this one here, you know, opposite over adjacent, you'd get 53 degrees. So if you add the two together, you know, from there to there, you get 67 degrees. So that's angle QPR. Now they'll have it more accurately. They would have done it to 1 decimal place. I'm just speeding things up. But that angle is 67 degrees. Because you've got these vectors of PQ and QR, you can find these lengths. It's the magnitude. So that's what I did here with those. You know, I found that was root 17, and that conveniently is 10. And the reason that I did that was because I saw that part B was find the area of triangle PQR. And if you remember from GCSE, the extra trigonometry at the higher tier at GCSE, you learn that the area of a triangle is always, using the trig formula, is that half BC sine A, as I always remember it. I always told I had set 2, it's the angle sandwich. You can work out the area of a triangle when you've got the two sides with the angle that they sandwich, the angle between them. And we've got this situation here, that's the angle sandwich, I used to tell mine. So the area of this is a half times the root, square root of 17 times 10 times the sine of, in this case, 67 degrees. 67.1 actually, it sort of works out. So whatever that gives you, okay, and I haven't worked that out, but whatever that gives you, that would give you the area, you know, of this triangle, and that's how you do the maths. So it's just a little bit of question 10 in there as well. Okay, so have a go at those. I hope you do these questions before you look and see me go through them, but just get some practice in, and we'll be solving problems with vectors next. Okay, thank you.